Hello, everyone. I would like to welcome you all to our Offer Holder Days, Virtual Offer Holders Day. I hope that you can hear me, you can see me well. If you have any problems at any time, if you can't hear or if you have any questions, please put them into the comments on the chat on the right-hand side. So I will start by introducing myself and colleagues today that we are going to join you in this session. And please be encouraged to ask any questions. So myself is Ahmed El-Saragi. I'm Associate Professor of Engineering Management. I'm a Director of Enterprise at the School of Engineering in the University of Lincoln. And I will be accompanied today with my colleagues Aliyu and Seung Ho, who Seung actually is the Mechanical Engineering Program Leader for MEng and BEng Program Leader for our Mechanical Engineering. And also I have Aliyu, he's one of our colleagues. He's a Senior Lecturer of Sustainable Energy. We are also one of our students, an MEng fourth year, Kirin. He's be joining us today. So please make sure to ask him question about his experience. And if you have any comments, as I said, or questions, please do ask them to myself or colleagues today. So again, this is quickly the first slide to introduce the team today, myself, Seung Ho, and Ali. And I think you can see them on the left-hand side. You can see everyone has in the screens. You have Aliyu and Seung Ho from the university, myself working from home today, and Kirin as well. So the first question, normally when we welcome you to our one of the in-person offer holders day, we would have made this more interactive or to get you involved with this thinking about what is engineering. But let me pick on this. And engineering is normally what all humanity faces: great challenges, problems, opportunities, and they turn to engineers to solve and resolve them. So this is a very simple way of describing engineering. So any problem that related to community, society, or in a sector, that they return to engineering to find solution or opportunity to enhance performance of a particular process or a product. Nowadays, the world is changing, and it's changing in a fast pace, and so on. The engineering is changing as well. So in the past few years, the nature of engineering itself has been, with the research agenda, has been changing dramatically, especially in the response of the global world crisis problems, i.e. global warming, globalization, climate change, and recently COVID-19, and the list keep going. Few numbers and facts to put you in the context of engineering and the engineering as opportunity, as working in different sectors or professionals. So there is more than 400k engineers employed in the UK at the moment, and the average of gross annual for engineers and engineering between 2006 was up to now is 42k. The other numbers that we want to highlight, or myself, I always say that's more than 100k from the workforce at the moment within engineering professional is going to retire by 2026. That means that there is a big opportunity, a large opportunity for engineering for exit opportunities. So 20%, above 20% of the engineering at the moment working in the UK will be retired. Roughly 20% them will be retired, and this will open up a lot of opportunities for graduates. Other key facts that more than 100 engineers and technicians are the core skills per year. So there is nearly around 100k opportunities for engineering and engineering related jobs for every year. There is about 80k engineering related jobs that rise every year. So there is a lot of opportunities for working within engineering, and this is what we are trying to highlight, that sometimes engineering, as I said, deals with different sectors that sometimes you don't expect that engineering is involved in this. So also what's good about engineering is engineering allow you to follow your passion, your area of interest, and you can work in different sectors. So you can work in rail, you can work on automotive, you can work on food and drink related, healthcare and medical care. We are going to discuss this later on with our new program in biomedical that jointly we deliver this starting from September 22 this year. And I can see that number of those who are registered for the offer holder day today, some of them are registered as biomedical. So I think we have 9 in total. If we have all of these 9 registered on our data and our records that turn today, so we have 3 at each of our programs. So 3 in mechanical engineering, 3 in electrical and electronics, and 3 in biomedical engineering. So as I said, this is a interdisciplinarity between some of the modules related to medicine, to the medical school, and some of them are related to the engineering school. So other sectors, aviation, aerospace, energy and oil and gas, defense and communication. So there is a lot of sectors, maritime, and a lot of sectors that are related into engineering. And this is the beauty about engineering, that allow you to work and follow your passion and the area that you are interested in. There is, unfortunately, because of some of technical issues, that there is embedded in this presentation 2 videos, but they are not be able, based on the system that I can't play them now, but colleagues will put these 2 links for you in the chat, and you can copy them and use them to refer to them later. Both explain, one of them explain what we have in terms of facilities in the School of Engineering, and one of them is related to one of the recent research that we are involved in at the school, and research team involved in healthcare technologies research. I'm not sure if colleagues can see the comments, if there is any kind of, just to make sure that the students or the participants today in this session can hear us and can see everything without any problem. Sometimes it's quite very difficult just to complete silent, and I don't know how people are can see us, can listen, hear us well. So normally we encourage students to be producers. We have a slogan here in Lincoln that we are very proud of the students as producers. They share knowledge. They are share responsibility about the learning, and also they are producer of the knowledge. The sound seems to be working. Yes, and 5 is already watching. Thank you, Naomi, for giving me this information. So if I can just maybe reflect with Kieran during this. Sorry, Kieran, to put you on the spot, but yeah, this is where if you can reflect on the nature of final year project, for example, and how the project can be linked to a particular problem, where we can link this to enhance the learning of the students, either as an individual project or as group project. So if you can give us from your experience, what do you think about this projects individually and in groups as well, and how they can enhance your learning?
Yeah. Well, for individual projects, for my 3rd year project, I did acoustic analysis, where I went into a church and looked at live streaming, because obviously COVID came around, which obviously impacted the world. And I looked at acoustic analysis, so looking at how we can maybe improve the acoustic performance of audio recorded in a live stream, like today, a live stream, but in somewhere where it's often only considered for ears and not for the actual recordedness. You might have like music playing, that's going to echo. You want to try and sharpen that out. So it's the ability to go from very theoretical and learning about these mathematical tools and being able to apply it, and obviously write a paper and get the formalities out of the way, but to be able to actually apply those skills, I really enjoyed, because it allowed you to have that transferring. And when applying for jobs and I'm talking to people, that's what they like. They like to hear that, oh, you've used that technique, oh, you've used it, not just you've learned it. Then my 4th year project so far is basically robotics within the medical field. We're looking at knee orthoplasty, and how to hold the knee optimally with a robotic. And then group projects, we've had was it the last mile? So looking at electrical vehicles, and how we can improve the energy consumption, because obviously refrigeration takes a lot of energy, and obviously vehicles nowadays don't have a lot of battery life. So how can you minimize the energy consumption of a battery? All applicable skills, because obviously when you get in industry, they're the type of problems you'll be hitting. When I'm talking to recruiters or jobs, that's what they're thinking. Like, okay, you've been able to apply that knowledge, you've been able to research, and so on.
So
very valuable.
So it's all about giving students ownership of their learning. So this is, as this slide show, because it's important. Sometimes we say in this fast pace changing now, content is not what really matters. It's how the process of learning and keep learning new stuff, because sometimes when you graduate, what you have got as a content is just obsolete, or maybe it's already old by itself. And this creates, as Kieran explained, this the staff students partnership as well. We encourage teamwork, and also we value a lot of the feedback, because we think, or we believe, that the feedback is important for students for their learning. And we try as much as possible that central within the college, that there is a team that can support students to link their project into industry. If possible, that we can feel it as a plus, but if not, at least it can be related to a real life scenario. But if it is the project itself, or a group of group of students working in one project related to industry, that can be really something good and can help them open up exit opportunity for future internship or placement that can lead to a proper job in the future. Maybe I can come back to you, Kieran, later about the field visits, and I think that you and your group has joined one of the field visits recently this year. But we can reflect on this when come about field visits and industry visits later on in the presentation.
Yeah, of course.
One of the important things that I want also, that we feel in Lincoln, that we are very very lucky to have lots of manufacturing, agri-food, low carbon companies and manufacturing. So Lincoln is really well known traditionally about the manufacturing and engineering heritage within the county. And this, just at our doorstep, a lot of companies that we create a lot of opportunities for our teaching, as we discussed in final year project, or even for our research to work with these industries. And the manufacturing and engineering contribute massively, more than 11 plus of the Greater Lincolnshire outputs in the economy. Also employs more than 40,000 people within the sector. So really, engineering and manufacturing is a vital contributor into the economic growth of the region, and as well as the UK as nation. I will hand over now to Seung Ho, my colleague, to go through quickly through how the curriculum, how the modules between the years in different programs. And if you have any questions related to mechanical engineering, please do ask them to Seung Ho. But if you have any other questions for other programs, we are not the experts, but we definitely welcome any questions to come via emails, or leave them in the comment, and I'll make sure that one of our colleagues in the school will pick, or our director of teaching and learning will pick these questions and come back to you and respond to you. So it's over to you, Seung Ho, to go through the curriculum, please. Thank you.
Okay, thank you. Can you hear me? I believe, yeah, okay, thank you. So we have a 3 existing program, and then we have now a biomedical engineering program coming this September. So now let me introduce the first 3. So mechanical engineering program is for BEng and also MEng. So in the year 1, year 2, we have some core module you were gonna study. So for example, one of these core module is mathematics. Mathematics is a unique a language for all engineering science, so it's quite important. And then there's a thermal fluid related module. So you will gonna study about energy and energy conversion, and also we have mechanical dynamic related module. So you will gonna study this kind of core module in the first year, and the second year there's some advanced, still dynamic and energy related module, but a little bit advanced you will gonna study. And then there's some engineering design challenge, which is one of the group projects. So you will gonna group together with your colleague and then will do some industry related group project. And then third year is similar, but in the third year, from the third year, you have lots of optional module. So if you want to study control side, then you can choose a control related module. If you want to study the power and energy stream, then you can choose more energy and power related module. And in the third year, you have a individual project. So you will gonna do some independent research with your supervisor, and then you will gonna do some pure academic research or industry generated research proposal. And also, if you want to study further for MEng level year 4, then again, there are some. Most of this module in MEng is now optional, so you can choose whatever you want in the year 4. And we have another group project in the year 4, mainly industry-based project. Okay, so this is a very general mechanical program from year 1 to year 4. And then we have another mechatronics program. Mechatronics program is basically somehow in between mechanical and electrical and electronic. Okay, so as you can see, the purple color. But this mechatronics program we have is only for BEng at the moment. Maybe later we can also offer MEng. And then similar program, but the electronic program. I will introduce this one too. I will hand over to Ahmad probably. I'm from the mechanical engineering background, so. And then again, that we have new biomedical engineering from this September. Again, this is only for BEng program. Now we are at the moment however we have already a established lab in the school, so you can enjoy this new equipment, new building, new step from this coming September. Okay, I will hand over to Ahmed. This is brilliant. By the way, do you have any question? Then please leave.
I think there is a question. Naomi said that there is a question, but I can't see on the screen. Can you pick this up?
Yep, I can pick. Are there any modules which include underwater automotive machinery?
I can pick this up, and maybe you can.
I think this is. I think you mentioned it's some submarine, right?
Yeah. Can I? And then you can elaborate more on this. Actually, we are not at the moment. We don't have any of this knowledge in terms of the modules itself. But we have one of our technical team. He's expert. He used to work. Mark. He used to work in Scotland as for ROV, remote operative vehicles underwater as well. And we are interested to deliver one of these activities to the schools that we go out for our outreach. But definitely, we will encourage this to have the supportive from our technical team, our technician. If you are interested to do a project to apply some of the engineering knowledge into the application for vehicles underwater or machinery underwater, that can be applicable in one of your final project. But no modules. But I think the principles of it can be covered in number of the modules. If any of colleagues wants to pick this up and elaborate more, maybe and Kieran as well, if you want, just let me know. Seung-ho, you want to say something?
Yeah, I think these, it doesn't matter which is specific area, but once we study about the principle of engineering, mechanical or electrical, then we can apply this fundamental principle into the different kind of engineering problem and project. So it really matter. It doesn't really matter. And also, we have another campus. I'm sure some in the South England. They are focusing on the more naval research. So we can collaborate. If you want to do something regarding this underwater or ship or whatever, then we can collaborate with them. Okay.
Yeah. Yeah. One of our professor, Minnie Sajti, is her background and area of interest in research is space, robotics in space. aerospace, and I think it's the same concept. If a machinery or a remotely operative operation underwater machinery can be also, as Seung Ho said, as number of the application based on the principle of engineering that you will be learning throughout your study. Continue on this. We have MEng, which is Kieran now is one of our MEng students, but also we have 2 MSc programs, which is a postgraduate taught courses based on 3 semesters on academic year, 2 semesters and a 3rd semester for each for dissertation. And one of them is MSc Mechanical Engineering, and the other one is MSc Engineering Management, which proven to be very internationally appealing. And we deliver some of these modules jointly between our school of engineering, and the business school as well. And we have MSc by research, and of course we have MPhil and PhD. So you can enroll in one of our MSc by research, not as the taught courses. The most important thing that our main 2 programs, which mechanical engineering and the electrical engineering, are both professionally accredited by the Institution of Mechanical Engineers, which is IMechE, and the IT for the electrical engineering. And it's very important to get your professional accreditation for your opportunities when you get into the market, and to be as a chartered engineer and practice. And also during your study, that will give you studentship or student membership, will allow you full access, I believe, on a lot of the resources, the materials that the institution that normal engineers or chartered engineers need to pay a membership for. But because of our programs are professionally accredited by these 2 professional institutions, it goes automatically for our students to get a student's membership. And I think it's just a simple form. I'm not sure if you, Kieran, want to say a few words about this in terms of the student membership. Are you aware of this? Or
yeah, I think I signed up in my 1st year, and I think it's free. But he came in and obviously got us to do it, because you can get access to stuff. There's some libraries, and they also do a couple of projects. They also do like meetings where they can just help with some skills if you need it. So it is quite nice to have.
Okay. Yeah. Brilliant. Thank you, Kieran.
And then if I may add,
that's absolutely fine.
Yes. So if I may add, because these courses are accredited by IMechE and IET, you as a graduate from any of these programs, you only need, I think, 3 years or so work experience for you to be chartered. So if the program wasn't accredited in the first place, then it would be very hard for you to get chartered easily. So, but because it is accredited with only a few years of experience, then you can become a chartered engineer, and that suddenly bumps your salary or pay or whatever, or even your standing within the institution, within your workplace.
So it opened up a lot of opportunities. Yes,
absolutely.
Thank you, Ali.
Yeah.
And as I said, just as in terms of our discussion today and inputs from our side, the curriculum, as we explained now with the modules and the final year projects, it's always we think what makes a good university a good university. What are the differences between a university or a particular academic school and the other one? Is what I always call it the 3 E's. So we have the education, which is pretty similar in all the subjects that can be delivered in one university to another university. So the curriculums are pretty similar in a way. But what really makes a good academic school or engineering school or a general university is the other 2 E's, which is the exposure and the experience. And we will talk a lot about these experiences and exposure, where the opportunities that the school and the college and the university provide for the students during the course of their study. So if there is any connection, as I said, to link your project or your teaching to the area of expertise of your supervisor or academic related to the research, most probably this research has been done by with the industry in a real life scenario to have an impact. It could be in a joint funded project for a national scheme or an international scheme. So that all give you the opportunity working in your project or on your modules and your teaching is this idea of the exposure. So you are exposed on opportunities that enable and empower you to get an opportunity, as I said, to build that trust with a particular industry that can open up an opportunity, an exit opportunity for you when you graduate. So it makes you more market ready or more or industry ready when you graduate. Also, that by different types of learning, not only acquisition but by collaboration teamwork that give you this experience of experiential learning, that you work with a particular problem, work with your colleagues, and also work with the community on a particular problem. So this is just quickly, we'll go through a number of the photos of the facilities that we have here in the university. It would have completely been different if you can join one of our on-campus events that we will show you around these facilities, and you can experience yourself. And we run activity, hands-on learning activity that you can practice something with your hands. But in the future, if there is any opportunity, and unfortunately we used to do a virtual tour by one of our technical teams member staff, but he is not able to join us today. The good thing, as I said, is always link the teaching to a research. So it's a research-led teaching. So that there is a group of research, different research groups related to agriculture, to healthcare, to drones, different applications, AI, and it's really good that this group of research group that has number of academics, and they connect that and inform their teaching in their modules, and also within the supervision of the final year projects. And this really makes your teaching not and the learning is not obsolete. It's more up to date and linked to research. This is another video that we will leave the link for it, but unfortunately it's not working today. The other thing that, as I said, is we work closely with the LEP, which is the Local Enterprise Partnership, which is a Greater Lincolnshire County. There are a lot of sectors similar to this on the screen now. Agri-food, a lot of funding happening, and this is number of our colleagues working in our Rise Home campus, working on a robotic kit that related to farming and strawberry picking, healthcare, manufacturing, ports, and logistics. I will this is just a kind of a mind map how we link. So we are very proud to have the TEF, which is the Teaching Excellence Framework, as gold in Lincoln. So this has been a standard national monitoring system for teaching. It's not only for research, but this is, and we were very proud that we got Teaching Excellence Framework as gold. But as the school here, we think that all our teaching and research need to be connected and well connected with the industry. So we are global partner to Siemens, and we are very lucky as a staff and students that we work alongside our colleagues from Siemens Energy. Their offices are the same. We share the same building where their offices, and their global training center where they train their international clients. And we are one of 5 global partners across the UK. Also, we have an industry advisory board, which is number of industry SMEs and large companies, where they sit in a board that inform our teaching and our research. So we get the feedback how to improve our like a continuous and sustainable dialogue between us and them, how we can enhance and do things better within our teaching, within our curriculum to improve this. And we are also a host of a Greater Lincolnshire Manufacturing Network, where we work closely with SMEs and large companies as well within the manufacturing and engineering. So this is kind of how we link, and we don't wait until our graduates, but we are trying to bring this and map this to our teaching and our research during the study, the course of your study. I think this is just a photo of Siemens main hall, and this is the companies that we work. A lot of companies, colleagues that we work with them on research, or as I said, an educational contract where we work with BAE Systems, for example, to train number of employees in from one of the Gulf countries for their Air Force employees. I will again hand over here because it's back to this field visit. I know that this is quite old, maybe industrial visit, but maybe if you, Kieran, want to say a few words about the opportunity that you and your colleagues have today had this year to visit one of the companies, and you are allowed to say the company. I think it's not a secret.
Yeah. This year in specific, when I was doing vehicle systems and control, I actually got to go to Hiriba Myra, which is a research test track center. And it was, I think, the greatness of it, they actually got to see how they did the tests for vehicles. The step steer, sinus steer. And they allowed us to get in it, experience it. They showed us the data from it. They showed us the tour of the facilities, what they use, and where to use your academic judgment, obviously, where it differs between experimental results and theoretical. They're like, you can trust your theoretical, but experimental is always better, but it allows you to build a lot better experience. So yeah, that trip was really well. And then I think I think I was the one for this year, the main one.
Yeah.
Obviously we had outreach and everything. It was really nice.
And yeah, I wasn't lucky enough to join this trip, but I heard from our colleagues and students that it has been very actually the top level of the work that design and the makes that firm makes, because that there is very strictly confidential, so you can't release any, I think, photos. Where we weren't allowed to take any photos because it's a kind of competition, because it's early designs. If one car making hear about that this designs has been maybe showed to others, or maybe share some data, so there is a confidentiality in sharing these data with them.
Yeah, when we went in, they literally strapped our phones. They bought like stickers to put over our phones, and if you peel it off, it invalidates the sticker, so they knew if you did it or not. And yeah, they got put in a minivan, went on the actual road tests, the different type of roads, and how you feel the van respond and everything. Yeah, it was nice to have that connection between sitting in a class, learning about the theory of vehicles instead, in the dynamics, to sitting in a vehicle on the test track, feeling it, and be able to link it really well.
But it was all high security. But it was high security.
Very high. Yeah, when you get through the front gate, you're okay, but getting through the front gate was the hardest part.
Okay.
In addition to that, generally we have sent a final year or MEng student to Volvo Proving Ground in Sweden to experience about the autonomous vehicle and their test center. So hopefully, once you guys join this school, you will have a chance to go there and have a look at some the autonomous vehicle, how this vehicle works, which control involved to this.
So everyone likes cars. So whoever wants interested in cars and just get into mechanical program, one of our mechanical programs. Thank you, Kirian. Thank you, Sungho. Before going into this, because this is I'm aware that this is the final maybe 2 or 3 slides that I'm going to talk with you about, is the opportunity about internationalization, study abroad semesters, a lot of work that we have been doing, we colleagues here in the school, to come up after UK went out from after Brexit, and we have enough opportunities via Erasmus for our students to go abroad for a semester abroad. We have worked with the Turing. I will explain all this in detail, but let me first go to Ali and ask you, Ali, to reflect on your research, because Ali is one of our colleagues who has a background in chemical engineering. We are not yet having a chemical engineering, but maybe in our future plans to have a chemical engineering. But Ali, his area of expertise in energy, biofuel, alternative fuels. But if you can give us some information, Ali, please, about your research and how you're working with colleagues, and also if you want to reflect on how we as a school within the College of Science, have we worked with other schools like chemistry or others, and how this can benefit academic, and how the impact on the students and their teaching as well.
Yes, absolutely. I can say a few words regarding that. So I think one of the key things that not just the UK, but most countries now are considering is transition from fossil fuels. So moving from diesel-powered vehicles or petrol-powered vehicles to in the future hydrogen before going full electric. So part of the research that we're doing here, has to do with hydrogen combustion engines as well. So, and we're looking at the combustion characteristics, for example, of hydrogen and even other gases as well. How to improve the combustion characteristics, and by extension, how to improve the performance of these vehicles. And then also regarding biofuels, we also have a fully fledged biofuels laboratory, which as students, you get to do some of the projects there if you're interested in that kind of thing. So, and that lab is fully instrumented. We do have gas chromatographs there, a gas chromatograph. And then we also have an equipment that is called the thermogravimetric analyzer. So what that does is, during the production of your biofuels, if you want to analyze what's going on as the biofuel is being produced. So these are state-of-the-art equipment that we use to measure those. So, and in terms of interdisciplinary research as well, we also do some work with those in chemistry, and they have lots of state-of-the-art equipment, that we can have access to, and also do some student projects on. We also do have access to this new £5 million facility at the bridge as well, which I think they started building it, and it's going to come on stream just when you're about to start. So all the equipment in that facility will be ready by the next academic year. So, and we do have a lot of collaboration with them over there. So they have scanning electron microscopes, transmission electron microscopes, also other characterization equipment, which are state of the art, which you don't find many of them around the UK. So I think we're lucky to have that facility here. So these are some of the facilities that you get to do projects on. And not only that, because this facility at the bridge, for example, was conceived so as to have to serve as a bridge between academia and industry. So we do have lots of companies, SMEs, small companies, and also large ones. And the projects that are there, you as a student can have an opportunity to work on some of those projects. So I think that exposure interdisciplinary also with industry is one of the key strengths that we have here. So I don't know if there's anything anybody wants to add.
No, I think this is brilliant. Thank you so much, Ali. And just to give an example, that we have been frequently receiving companies that they work in net zero, for example. Yes. They are moving from somewhere internationally or somewhere in the UK, get closer to us in the Humber region, to start in the Freeport region to start their industrial clusters. We have received, me and you, 2 weeks ago, a company called Penzana, for example, and
yes.
Graduates. Unfortunately, we don't have a graduates from chemical engineering, so they can just want them to get jobs and just get internship. But we have started a collaboration with them that we might come up with a new program that can provide them with their needs in terms of graduates. And similarly, we work with Siemens, Schneider, with other companies that, as I said, within the advisory board for the school, that we make sure that our graduates are ready for these opportunities. And I think in terms of the graduate employability for our mechanical engineering, mainly we are within the sector 80%, or maybe something around up between 80 to 85% of our graduates get jobs in the area that they have been studying. And this is really a key now for universities, and they monitor universities if their graduates are working in the field related to their studying subject. Back again to this idea of study abroad, we believe that we are preparing our graduates not for opportunities only in the UK or Europe, but also internationally. And we receive lots of international students, and we believe that this is enhancing the skills and the competencies of our students and future graduates to be citizens of the globe. And by number of our international partners and all over the world. We have a number of international universities. We have some kind of agreement mapping for curriculum. So we have designed in second year that there is a study abroad or study semester where you can go to international, particular international partner. We have already mapped the curriculum with their curriculum, and you can spend either a semester abroad or maybe a year between year 2 and year 3 as a gap year to do a half year, a semester academically there, and maybe a work experience. Some of these opportunities are funded by Erasmus Mobility for staff and students, and we work with a number of universities in Latin America and in the Middle East and Jordan as well. And we receive from them. The new scheme, as I said, after Erasmus, that had been we have been successful in securing this for our students as well, is the Turing scheme, which is a UK to replace the Erasmus, but only for sending out students rather than receiving from other international partners. So we have a number of mobilities, and I think we have started marketing this after going back to normal after COVID. Things will be hopefully much better from during COVID, and we do encourage a lot our students to take these opportunities to work with our and spend a semester abroad, or maybe any internship. It doesn't need to be a full semester. It could be up to 5-6 weeks during summer as work experience, or as mobility of an exchange with other culture and different settings. And it's really valuable, and it's add a lot on their skills and competences for when they graduate. I will end with this very nice photo on that slide. So it's a lovely place to have your graduation in the Lincoln Cathedral. We are very proud of Lincoln Cathedral. That I think my background is energy and architecture engineering, and I've studied myself this piece of architecture. It's a masterpiece of architecture before even moving to the UK or coming to Lincoln particularly. It's really nice. We are all looking forward to have you joining us in one of our programs, and then to get your graduation in this amazing, marvelous place or building. I will end my talk here, but it's over to colleagues if they want to add anything, or just maybe ask me, or just start the discussion. And if there is any comments or questions in the chat, please do pick them up. Naomi, let us know, or if any of colleagues can see the comments on the chat. I can't, but just let us. We still have time, like 15 minutes, so we can have Q&A session, just discussion. Kirin, if you want to say anything, or Ali, feel free, Seung-ho. It's over to you. Thank you so much for joining us today, and for joining the session as well. So it's over to you now. Thank you.
Thank you. So if anybody has any question, please feel free to pop them in the chat, and then we'll be able to do our best to answer that question. So please feel free. And the question may be anything about either academia or even a campus life, and I'm sure Kiran should be able to shed more light on that for you.
I can see some question from Spencer Gibson. Ahmed and Seung-ho, are you also currently doing research? So yeah, we are doing some research. So let me first introduce my research. I'm doing a hydrogen and combustion, and the sound noise generation from hydrogen combustion. Hydrogen combustion is, as you already know, there are no greenhouse gas emission from hydrogen combustion, only water vapor and then nitrogen as an inert gas. However, the thermodynamic property of hydrogen is very different with normal compressed gas. So in order to use hydrogen combustion, we need to understand what's going on after burning of the hydrogen. So I'm typically interested about the flame propagation of the hydrogen combustion and the flame dynamic. Dynamic means of the motion of combustion. And also sometimes they generate unwanted a acoustic sounds like when you look at it at the laptop, you can hear the very acoustic noise. So one of my research topics then how we can remove this kind of noise and make a stable combustion. So that's my research. Over to you, Ahmed.
Yes, thank you, Sungao. Yes, my research area goes around energy management and energy in general. And recently, I have won a KTP with one of the industry, and we are very proud of this in the school. And we work in it as a team, myself and a number of colleagues. And this is it's with one of the large companies here in outside Lincoln, and they called Iminox. And KTP is a knowledge transfer partnership, where actually we have been introduced to this company maybe 2 years ago, and they work in the low emission zone for large vehicles. So how they can convert. They own the technology how to retrofit exhaustion and to reduce the CO2 emission from large vehicles like large public transportation buses, for example. And we are working with them now to test how alternative fuels can be used in their technology. We can't say a lot about the research itself as for confidentiality and the non-disclosure agreement that we have signed, but it gives a very good example where we work and we encourage our colleagues, research teams, to work closely with what really the industry means. This opportunity will allow us, one of our graduates, or open to anyone, that we can recruit a member to join the company, and its percentage of this is funded by a national scheme where the company itself can benefit from this expertise, from this associate, to transfer the knowledge from the university into the company where a particular problem that the company wants solving, and they will not pay a full percent or 100 of this person to employ them, but a percentage based on the size, is a small, medium size, or a large company. But just to cut story short, is this is the idea of encouraging all our research teams and colleagues who work with industry and to have an impact, because we are required as a university to have impact. So our research, we are not doing research for the sake of research, or we are doing teaching for the sake of teaching. We have to have an impactful outcome that can make change on a business or an industry, in the real life, on a community, in a real life scenario. So yes, in summary, my research area is around energy management and innovation management, and also energy within buildings. I'm working closely now with Ali and other colleagues outside the college, in other colleges, to simulate thermal properties into buildings as well. So we test and do some simulation in different spaces within buildings. Yeah, I hope that answered the question, but I'm not sure. Naomi, I think, has said that there is no more questions in the chat. So if any colleagues want to say anything, I'm not sure if there is still some attendees in the virtual room, or all gone. Kirin, you want to say something, or?
Yeah, I can.
Unmuted. I can see that you're unmuted. So I said maybe you getting ready to. Yeah, I think you mentioned something. I'm not. You mentioned something about your experience with outreach, and I think if you want to
that was really nice. So,
one of the outreach as well, that can be a good example to explain what outreach is.
Yeah. So with outreach, I got the opportunity to go to Boston and go to Boston College and talk to some level, I think it's level 3s and sometimes level 4s and 5s, engineering students there, and see if, engage with them to see how, if they want to maybe progress to the university, even general university career, showing them the basics of mechanics, static and dynamic balancing stuff, got to show them the electrical. My favorite part's always the sort of mechatronic side of stuff, where you get to combine the knowledge, where you get to see the suspension system wobbling down. Like you get to see the computer with the software to an actual physical system, and that was really nice. And yeah, everyone loved it, getting intrigued, getting involved. And then when you're talking to them, you get in that whole idea of, yes, you've got the theory, but it's all be able to apply. And that's what you learn, be able to apply it. And that transfer of knowledge is just brilliant. I feel like the tips I'd have for general university is, never be afraid to ask lecturers stuff. Even if it's outside the scope of a module, like with my third year with state space control, I got to do over the summer with a lecturer with non-linear stuff. Getting to experience something completely outside the course because I had an interest, and the lecturer was able to go, yeah, I'll happily drive that interest for you. So don't think it's always bounded to university and then only going to answer university questions. If you have an interest in, let's say, your field of research, you'd happily point them in the right direction.
Yeah.
And I think that's for any lecturer, really. If you really are showing a passion, they're not going to go, oh, sorry. They're going to be like, no, come on, yeah, happily show you.
Yeah.
So just ask questions whenever you need to, and don't be afraid to. And then just stick in, and don't let any assignments last minute.
Yeah. I think if I reflect on outreach as well, this is one of the things that we really value in our school, going out to FE colleges or just high schools and work with the students. And we want to change perception as well about STEM and general and specifically about engineering, and give right information about what engineering is about, to encourage female and male youngsters or students to pursue engineering as a profession or as a career. So this is our duty, paying back to community as well, to change this perception and to give the right information about engineering. And also support activities like Kieran that he mentioned about. This went out with Ali and colleagues to Boston College. So it's a kind of marketing for our programs, but also it's in a very positive way, building that trust with a particular school, correcting the information about engineering in general, make students practice things with their hands. We work also with UTC, with the University Technical College here in Lincoln, and we run a number of projects with them. They have an engineering year 12 and year 13, and we send that as a potential for us to come and continue in one of our programs. So we do a lot of these outreach activities, which are around project, around hands-on learning with the students and their school teachers in different fields or different subjects in engineering. And we also encourage our students, like Kieran and others, postgrad or undergraduate, to join the team going out on one of these outreach, because it's important to showcase this is our product, this is our outcome, and I think always have this feeling that students do believe students rather than they believe someone else. So if they hear it from someone like their age or closer to their age, they are able more to take the advice. And so I would like to grab this opportunity to thank Kieran for joining and his colleagues joining these outreach activities.
Thank you.
Thank you, Kieran.
Thank you.
Do we still have any more questions, or?
I don't think so.
I don't think so. I think that's it. No more questions.
Okay, brilliant. So yeah, if I'm not sure if you'll be able to get a copy of this presentation or not, but please, for those who are still with us attending this, there is my email. You can look up for any of our profiles on the university website. You can get to any or email. Just feel free to drop us a line, ask your question, get in touch. It will be definitely a good opportunity if you have the opportunity to come in person and come in one of our on-campus events.
Yeah, there's one question from same Spencer Gibson, that what stuff could I have done if I was able to come to the physical Oppo Holders Day? So
that's a great question.
Sorry,
I can tell you. Well, if you come to our physical Oppo Holder Day, you will have some hands-on experience. Like we've now arranged a couple of hands-on experience for you guys. or whatever, some mechanical or electrical. So you have you can have some taste regarding engineering. So
Yes,
that's the good thing for you.
Yes. So, for example, you can have a play with the virtual and physical ball and beam. So equipment, you can play around with it. You feel the haptic feedback, on that equipment. Then there's also the inverted pendulum, which is a classic control problem. So we have that kit here, so you can play around with it as well. See how when you move the pendulum, how it gets back into position just by the control equipment that is there, and you can play around with the tuning parameters as well, and then see how it reacts. Then we also have some of the statics and dynamics equipment that you can use as well. You can have a play around with. You see them and play around with them. So these are the things you'd get access to. And then in addition, apart from that, you also get a tour of our labs here. So you get to see a selection of the labs that we do have here. For example, Ahmed showed one picture there with the robots. So you get to see the robots in the robotics lab. Yes. And then also so all these pictures here, you would actually have a tour, like the Siemens gas turbines workshop. You're going to go there and have a look. Yep, here.
Yeah.
So, and then also here we have the anechoic chamber, which Kieran, I think, must have done a project there. So you have you go into this facility and hear how really silent it is because of those cones you see on the wall.
Yeah.
And then also you also go around and see your future classes as well, the computer labs. You see all of them. And so that's within the building here. And there's also, I believe, a campus tour as well. So you go around and see the campus for yourself. I think we have a very beautiful campus here. You see the Brayford pool, and yes, and the boats and the surroundings. So I think you get to feel the university better than if it's a virtual of a whole day.
Yeah, seeing is believing. Yes, it's and definitely. Having an experience hands-on, as Ali and colleagues mentioned, it's a completely different story. We used to some of these virtual events because of COVID, unfortunately, but we do encourage colleagues or participants, when you have the opportunity to visit us on campus, it will definitely make a huge experience. Engineering is all about hands-on, is all about practical, is all about lab work, is about touching and try and error. We can rely sometimes in emergency, as it happens online, but it's not our default. We want to keep it all the time face to face and have the real experience for our students. Thank you, Naomi, for reminding us that's 2 minutes left for this streaming. I think it has been very, very useful from our side. I hope that audience and participants have felt the same. I would like to thank all my colleagues, Seung Ho and Ali and Kieran today. We have been fantastic interaction between four of us, and I think we try to do our best to reflect on our different experiences as academic, as staff, and as students, and give you a bit of a taster of what you can find in the School of Engineering at the University of Lincoln. From me, thank you to everyone who has joined today, and also thanks for all audience and the team behind the scene who prepared all these technology and digital platform from StreamYard. And so thank you for our digital marketing team, and Naomi and her team for doing this and running it as smoothly as possible. And I wish you all a very nice evening. There is a lot of football, I think, important football happening in 1 hour time. So, so who those are watching football, just enjoy your evening. Or you can do something else useful.
I'm watching actually. So
okay, thank you.
okay, bye-bye.
Thank you, everyone.